Meanwhile, the discovery of a new exoplanet has astronomers excited that it could be indeed signs of life. The planet, a bit smaller than Neptune, has been found to potentially have oceans and atmosphere with carbon dioxide.
In the boundless theater of the cosmos, a monumental discovery has emerged, unfolding a new chapter in our understanding of the universe. The renowned James Webb telescope has pierced through the celestial mystery, revealing sights unseen, capturing images of a distant world that stirs both imagination and scientific inquiry. A realm so alien, yet tinged with the familiar whispers of the cosmic tapestry, has been unveiled, beckoning us to explore its depths and marvel at its uniqueness. Each pixel of the image radiates with tales untold, stories of distant skies and foreign landscapes, waiting to echo through the corridors of human consciousness. So, prepare your senses for an unveiling, as we, Universal Narratives, are here to guide you through the tapestry of this newfound knowledge, illuminating the darkened canvas with the gleaming light of discovery and understanding. Welcome to a narrative woven with threads of celestial wonder and scientific endeavor, where curiosity and discovery merge into a symphony of universal exploration. The James Webb Space Telescope by NASA, launched in December 2021, is a window into the unknown, a watchful eye focused on the infinite cosmos. In its mission of exploration, this extraordinary telescope has revealed a new and fascinating world, announcing a discovery that has left the international scientific community in awe. The exoplanet K218b, located in the constellation Leo. The JWST is not an ordinary telescope, but an advanced infrared observatory located about 1 million miles from Earth, with a fixed and wide field of view that extends into deep space. Its main functions include the detection and detailed analysis of exoplanet atmospheres, as well as the search for conditions that could be favorable to life as we know it. But the discovery of exoplanet K218b was not accidental, but the result of careful observation and analysis of collected data. The first time we heard about K218b was in 2016, during NASA's K2 mission. On that occasion, the exoplanet showed intriguing variations in light as it transited its host star, which prompted scientists to further investigate the characteristics of its atmosphere and surface. K218b has therefore been revealed as a hydrogen-rich planet with vast oceans believed to exist beneath its atmosphere. The presence of carbon-based molecules in the atmosphere, essential for life as we know it, has strengthened the hypothesis that K218b could be a hospitable environment for life. The discovery of dimethyl sulfide, DMS molecules in the atmosphere of K218b has further emphasized this possibility. As on Earth, DMS is primarily produced by living organisms, particularly marine phytoplankton. The presence of DMS on K218b is a groundbreaking discovery, suggesting the possible existence of life on this distant exoplanet. However, these discoveries must always be approached with cautious optimism. The confirmation of life is a complex process that requires more data, meticulous analysis, and validation. The distance from its star, the composition of its atmosphere, and the characteristics of the host star all play a fundamental role in determining the possibility of a planet hosting life. Although K218b shows promising signs, definitive confirmation of life requires more than just the presence of certain molecules. K218b, with its promising atmosphere and position in the habitable zone, tempts us with its potential. The composition of its atmosphere and the absence of certain molecules suggest the existence of oceans beneath its hydrogen-rich atmosphere, potentially creating favorable conditions for life. These are the stories that the JWST tells us as it explores the grand universe, revealing its mysteries and infinite possibilities. The universe is not just a void dotted with stars, but a narrative waiting to be told. With the JWST, we have learned a lot about K218b, and this data has been collected in just 2 transits. To put it in perspective, the results obtained from 1 JWST transit observation are equivalent to 8 observations with the Hubble telescope over several years and in a narrow wavelength range. If the JWST can provide us with so much information in just 2 transits, imagine the future possibilities. This is probably a first demonstration of what the JWST can observe in exoplanets in the habitable zone, and only time will tell whether life exists on K218b or not. These discoveries represent the first steps in a journey of exploration and understanding that could one day lead us to discover that we are not alone in the universe. The atmospheric conditions of K218b, its position within the so-called habitable zone, the presence of organic molecules and compounds like dimethyl sulfide, known to be produced on Earth by living organisms, make this exoplanet an extremely interesting candidate in the search for extraterrestrial life. However, the confirmation of extraterrestrial life is not a simple task, and the discovery of these chemical elements, although suggestive, is not definitive proof of the existence of life forms on K218b. The debate about the nature of exoplanets and their atmospheres is alive and vibrant in the scientific community. K218b, with its size falling between that of Earth and Neptune, occupies a particular position in this debate. While the presence of methane and carbon dioxide in its atmosphere suggests the existence of water oceans beneath its hydrogen-rich atmosphere, many aspects of these exoplanets and their atmospheres remain unknown. These mysterious and fascinating celestial objects raise significant speculations regarding the possibility of hosting life. In this context of discovery and exploration, the question of life on K218b remains open. The planet's atmosphere contains methane and carbon dioxide, but lacks ammonia. This atmospheric composition suggests that the underlying ocean could be a suitable environment for hosting life, even if conditions are similar to those on Earth. However, not everything that glitters is gold. Another exciting revelation brought to light by the JWST is the discovery of the dimethyl sulfide, DMS molecule in K218b's atmosphere. DMS is a poorly studied gas that has a pungent and almost sweet odor, and is a significant source of sulfur emitted into the atmosphere on Earth. This gas contributes to the formation of clouds that block and reflect solar radiation into space. Its presence on K218b is a game changer because DMS is only produced by various forms of life on Earth, mostly emitted by phytoplankton in marine environments. All these elements, taken together, indicate that K218b is an extremely interesting exoplanet and a promising candidate in the search for life beyond our planet. Each new discovery in this field raises new questions and perspectives, fueling our curiosity and desire to explore the universe we live in. With tools like the JWST, we are able to push further, exploring new worlds and seeking answers to humanity's deepest questions.